Okay, today we're going to learn lesson 8, the inverse sine, cosine, and tangent functions. So after this lesson, you will be able to understand definitions of the inverse sine, cosine, and tangent functions. You will also be able to sketch the graphs of the inverse sine, cosine, and tangent functions, understand and interpret the main properties of the inverse sine, cosine, and tangent functions, and solve problems involving those functions. Okay, so first let's have a look at the inverse sine function. The inverse sine function is actually a reverse process of the sine function. So for example, for the sine function, domain range is illustrated here. For any angle in the domain, there is a sine value corresponds to this x, right? This is called the sine function. The cosine function is just the inverse process. That means given any value in the y, set y, which is a sine value, right? Which should range between -1 and 1. There should be a corresponding angle in the x set, right? This reverse mapping is called the inverse sine. So because sine function is a periodic function, right? So for any given y here, that corresponds to an infinite number of x, right? So in order to make the inverse mapping be a function, we need to restrict the domain of the inverse sine to within a period, right? So we restrict this to minus half pi to half pi. In minus half pi to half of pi, for any given sine value, there is only one possible angle that corresponds to that sine value, right? Okay, so the inverse sine function is denoted by this symbol here. Y equals arc sine x, or sometimes you can also write it like y equals inverse sine x. So this means, first of all, y is an angle, right? In radian measure. Second, the domain of y here is between negative, the restriction for y is negative half pi to positive half pi, right? And because y is an angle here, if you write y equals arc sine x, that means the sine value of y equals x. So this is the interpretation of the inverse sine function. Okay, I'll repeat. If you have an expression like y equals arc sine x, or y equals the inverse sine x, this can be interpreted as below. So first of all, y here is an angle in radian measure. Second, this angle must lie within minus half pi to half pi. Third, the sine value of y equals x. This is the interpretation of this expression here. Okay, so the inverse sine function is, as I said, is just a reverse process of the sine, right? So these two functions will have a line symmetry about the line y equals x. Understand? So if you look at the graph of y equals sine x on the right, in this interval, it will look like this, right? And if you look at the y equals arc sine x, and domain is -1 to +1, and corresponding range is from negative half pi to half pi. It is just the y equals sine x reflected in y equals x. Understand? Okay, the main properties of inverse sine. First of all, the domain is -1 to 1, right? Because the x here is just the sine value of y. If it is a sine value, it must oscillate between -1 to 1, right? Second range is -half pi to +half pi, as we have just said here. Third, this is an odd function because it's just inverse sine. Sine is an odd function, so inverse sine is also an odd function. The y-intercept is 0, 0. X-intercept is also 0, 0. Increasing interval is -1 to +1. So this is an increasing function. Inverse property. We have the following inverse property. If alpha is between -1 to 1, then we have the following relationships. First, sine, arcsine alpha equals alpha. Why? Because you can just think of, for example, theta equals arcsine alpha. Arcsine alpha is an angle, right? So let's denote it with an letter theta. So if theta equals arcsine alpha, that means theta is an angle, right? And the sine value of this angle is alpha, right? So we have sine theta equals alpha. That means sine arcsine alpha equals alpha. Understand? And we have also the following relationship here. If beta is between -half pi to +half pi, then we have arcsine sine beta equals beta. Why? Because arcsine sine beta is just an angle, right? If we denote it using a letter, for example, arcsine sine beta, we denote it as theta. That means theta is an angle, and the sine value of theta is here, right? So sine theta equals sine beta. And because beta is within -half pi to +half pi, so in this interval, the function is monotonically increasing, right? So theta must be equal to beta. So we have the relationship here, arcsine sine beta equals beta, okay? All right, so let's have a look at the practice here. I'll give you 3 minutes to think about these questions. Okay, have you finished? All right, first of all, what is arcsine minus square root of 3 over 2? So arcsine is an angle, right? And this angle must lie within this interval, right? So in this interval, we'll find an angle that the sine value of this angle is minus square root of 3 over 2, right? So that means, for example, this is minus half pi, and this is half pi, right? So in this interval, we need to find an angle that such that the sine value of this angle is minus square root of 3 over 2. So where is this angle? We know that sine 1/3 of pi equals square root of 3 over 2, right? And sine minus 1/3 of pi equals square root of 3 over 2, right? So of course, minus pi over 3 is within this interval, right? So here we know that arcsine minus square root of 3 over 2 must be minus pi over 3, right? Okay, next, arcsine 3 over 2. So this means we need to find an angle, for example, theta, and the sine value of the theta is 3 over 2, right? And according to the definition of theta, the range of sine theta is -1 to 1. It cannot be 3 over 2, right? So this angle here is undefined. Okay, next, sine, arcsine 1 over 2. Arcsine 1 over 2 is an angle, right? Assume we denote it as theta. Arcsine 1 over 2 is an angle theta, and we know that theta is within minus half pi to positive half pi, and the sine value of theta is 1 over 2, right? So sine, arcsine 1 over 2, of course, is 1 over 2, right? Okay, next, arcsine sine a quarter pi. So arcsine something is an angle whose sine value is sine a quarter pi, right? So suppose this angle is theta. We know that sine theta equals sine a quarter pi, right? And because sine is within negative half pi to positive half pi, so of course theta here is pi over 4, right? Okay, you can also check the complete solution in this lecture slides after the class, right? Okay, next let's have a look at the inverse cosine function. So similarly, the inverse cosine function can be expressed as y equals r cosine x, or y equals cosine inverse cosine x. The interpretation of cosine y equals r cosine x is as follows. First of all, y is an angle, right? Second, this time, unlike the arc sine function, or angle y here lies between 0 and pi inclusive. Okay, so note here, this is different with the arc sine. Okay, because in this interval, the cosine function is decreasing, right? As you can see here in the right, in the graph shown on the right, this is a graph of y equals cosine x with domain restricted to 0 to pi, right? If it restricted to 0 to pi, that means for each given cosine value x, there is only one x value, which is the angle corresponds to the cosine value, right? So only in this way, the reverse process is a function, right? Okay, so third aspect is cosine y equals x. So I'll repeat. If you have an expression like this, y equals arc cosine x, that means three things, right? So first of all, y is an angle in radian measure. Second, y is between 0 and pi. Third, cosine y equals x. That means the value of the cosine value of y equals the x here. Understand? Okay, next, let's have a look at the main properties of the inverse cosine. First of all, the domain, of course, is -1 to 1, right? And range is 0 to pi. So as shown in the graph here. Next, it is neither odd or even function. The y-intercept is 0, half pi. And the x-intercept is 1, 0. Understand? Okay, the decreasing interval is -1 to +1. And also we have the inverse property here. For example, if alpha is between -1 to +1, then we have cosine or cosine alpha equals alpha. And if beta is within 0 to pi, then our cosine beta is beta. Okay? Please have a look at the inverse cosine function here. And do you take any notes you need? And we're going to use that note to solve the questions below. Okay, so let's have a look at a question. Find the exact value of each of the following expressions without using technology. First, what is arc cosine square root of 2 over 2? Next, what is a inverse cosine of cosine 4 pi over 3? Okay, I'll give you 2 minutes to think about these questions. All right, let's have a look at the solutions. First, note that this is an angle, right? This angle has a cosine value of square root of 2 over 2, and this angle lies within 0 to pi, right? And note that in this interval, we have cosine a quarter pi, right? Cosine a quarter pi equals square root of 2 over 2. So that means arc cosine square root of 2 over 2 is a quarter pi, right? Okay, next, let's consider if we let the inverse cosine 4 pi over 3 be an angle. This is apparently an angle, right? So let's use a letter alpha to denote this angle. Then we know that the cosine value of alpha must equal to the value here, right? Which is cosine 3 pi over 4 pi over 3, right? And we know that alpha is, of course, within 0 to pi. So that means from 0 to pi in this interval, we must find a angle alpha such that the cosine alpha must equal cosine 4 pi over 3, right? So where is 4 pi over 3? 4 pi over 3 is just pi plus another third pi. So this is 4 pi over 3 here, right? So in this interval here, this angle here must have a same cosine value, right? So this angle here is pi minus pi over 3, right? Which is 2 pi over 3. So that means the inverse cosine 4 pi over 3 equals 2 pi over 3. Understand? Okay. Also, you can check the solution in this lecture slides after the class. Okay. All right, next let's have a look at the inverse tangent function. The inverse tangent function can be expressed as y equals arctangent x, or y equals inverse tangent x, okay? And it can be interpreted as the following aspects. So first of all, y is an angle, right? If you express it y as arctangent x, y is an angle in radian measure. Second, y is within the interval minus half pi to half pi. Why? Because tangent theta is also a periodic function, right? We must restrict the angle to half pi to pi. That means one of its cycles, in order that the reverse process is also a function, right? Only in this way, if you choose any tangent value, that corresponds to a unique angle x, right? Okay, third, tangent y equals x, okay? So basically this is the angle. And this angle lies within minus half pi to half pi. And then the tangent value of this angle is x, right? So if you have an expression like this, that means these three aspects. Okay, next, the main properties of this function. First of all, the domain. If you look at this graph, this is a graph of arctangent x. The domain is negative infinity to positive infinity, which is the range in the tangent x on the right. Okay, the range of the arctangent is, of course, negative half pi to positive half pi, right? Okay, next, this is an odd function. Y-intercept is 0, 0, and x-intercept is also 0, 0. And there are two horizontal asymptotes. First one is negative half pi, and next one is half pi, right? And the increasing interval is from negative infinity to positive infinity. So basically, this is an increasing function in the set of R. Okay, of course, we have also the inverse property. If alpha belongs to the real number set, then we have tangent arctangent alpha equals alpha. And if beta lies within minus half pi to half pi exclusive, then we have arctangent tangent beta equals beta. Okay, and please have a look at the slides and do take any notes you need. And we're gonna use them to solve the following questions. Okay, I'll give you 2 minutes. Have a look at this. All right, let's do a practice. Find the exact value of each of the following expressions without using technology. First, what is the value of arctangent square root of 3? Next, what is the value of tangent arctangent minus 7? Okay, I'll give you 2 minutes to think about this question. All right, let's have a look at the solutions. Okay, first of all, arctangent. This is an angle, right? This is an angle, and the tangent value of this angle is square root of 3. And we know that this angle must lie within minus half pi to positive half pi, right? So in this interval, which angle has a tangent theta as square root of 3? We know that tangent third pi is square root of 3, right? And a third pi is within this interval. So that means the angle we are looking for is 1/3 pi, right? Okay, next, tangent arctangent minus 7. So this is an angle here. This angle has a tangent value of minus 7. Tangent, this angle must equal minus 7, right? According to the inverse property, we know that tangent arctangent minus 7 is indeed 7, right? Okay, so we can also check the complete solution in this lecture slides after the class. All right, so next let's have a look at some problems that involves the inverse sine, cosine, and tangent functions. Okay, first of all, let's have a look at this question. Given that C is arctangent 3 plus arcsine 5/13, find the exact value of cosine C. Okay, I'll give you 5 minutes to think about this question, okay? Okay, any thoughts? All right, so basically C is a sum of two angles, right? We want to calculate the cosine value of C. That means we want to calculate the cosine value of the sum of two values. So we can consider using the compound angle formula, right? So for example, if you denote the first angle as alpha, second angle as beta. So these are two angles, right? We want to calculate cosine alpha plus beta, right? Which is cosine alpha cosine beta minus sine alpha sine beta, right? Remember the compound angle formula. So we need cosine value of alpha, sine value of alpha, cosine value of beta, and sine value of beta, which we have already has this one, right? Sine beta is simply 5/13. So we need to calculate the rest of the values here. All right, so first of all, let alpha be arc sine 3. And then we know that alpha, because it's arc tangent 3, so alpha must lie within minus half pi to half pi, right? And we also know that tangent alpha equals 3. Okay, so tangent alpha squared plus 1, which is 9 plus 1. This is actually secant alpha squared, right? According to the Pythagorean identity. And secant alpha squared is cosine alpha, the reciprocal of cosine alpha squared, right? So that means cosine alpha must be 1 over square root of 10, right? And we also know that sine alpha squared equals 1 minus cosine alpha squared, which is 9/10, right? That means sine alpha equals positive or negative 3 over square root of 10, right? But note here, alpha is negative half pi to half pi, and tangent alpha is a positive value, right? That means alpha is actually between 0 and half pi, right? So sine alpha must also be positive. So sine alpha is positive 3 over square root of 10, right? Okay, now we have sine alpha, cosine alpha. And then let's calculate cosine beta. Okay, let beta equals arc sine 5/3. Then we know that because it is an arc sine, then this angle must lie within negative half pi to positive half pi, right? But because sine value here is positive, right? So we know that this angle must lie within 0 and half pi, right? And also sine beta equals 5/13. And cosine beta squared equals 1 minus sine beta squared, which is 1 minus 25 over 169, which is 144 over 169. So that gives us cosine beta is actually the square root of 144 over 169, right? Because beta is in the first quadrant, so cosine beta must be positive, which is 12/13, right? Okay, so now we can calculate cosine uppercase C, which is cosine alpha plus beta, which is cosine alpha cosine beta minus sine alpha sine beta. And then we can just put all this value in, right? Cosine beta is here, 1 over square root of 10 times cosine beta, which is 12/13. minus sine alpha is 3 over square root of 10 times sine beta, which is 5 over 13, right? And we can calculate this. This is actually minus 3 times square root of 10 over 130, okay? This is our final solution. And you can also check the clearer complete solution on this lecture slides, okay? Okay, I'll give you 1 minute to review this solution. And then we'll go to the next question. All right, let's have a look at the next solution, the next practice. Solve for the exact value of x in the indicated interval 0 to pi, given that 5 cosine 2x is 2. Okay, I'll give you 3 minutes to think about this question. Okay, any thoughts? All right, so we can start from the given information. We know that 5 cosine 2x equals 2, right? And this gives us cosine 2x equals 2 over 5, right? And we also know that x is between 0 to pi inclusive. So that means 2x must be within 0 and 2 pi, right? So 0 to 2 pi means from 0 to 2 pi, we need to find an angle that such that its cosine value is 2 over 5, right? So that must be 2 values, right? Of course, one of these solutions is 2x is just arc cosine 5 over 2, right? This is one of the solutions. For example, this is 2x. And in the interval 0 to 2 pi, if you have a solution here, you must have another solution here, right? This is actually 2 pi minus arc cosine 2 over 5, right? Okay, suppose here is arc cosine 2 over 5, and this angle here is 2 pi minus arc cosine 2 over 5. Do not forget there is another value in the interval 0 to 2 pi, okay? So that means x equals 1/2 of arc cosine 2 over 5, or x can also be pi minus 1/2 of arc cosine 2 over 5, right? So there are 2 solutions, okay? Also, you can check the complete solution in this lecture slides after the class. All right, so let's have a look at another problem. This is a real world problem, okay? I'm not gonna read it for you here. Please spend 5 minutes having a look at this question and try to solve it by yourself. Okay, I'll give you 5 minutes. You can start now. All right, have you finished? Let's have a look at the solutions, okay? All right, first of all, write a function for alpha in terms of x. Okay, so note here, so tangent alpha can be expressed as tangent theta subtracted by beta, right? And tangent theta minus beta can be expressed using the compound angle formula for tangent, right? So tangent theta minus beta is just tangent theta minus tangent beta, right? Over 1 plus tangent theta tangent beta, right? And then we can calculate tangent theta and tangent beta in the two right triangles shown in the graph. So first of all, tangent theta. Tangent theta is 205 over x, right? And then tangent beta. Tangent beta is 80. This triangle here, 80 over x, right? Okay, and then 1 plus 205 over x times 80 over x. And then we can simplify this expression to 205x minus 80x over x squared plus 16400, which can be further simplified to 125x over x squared plus 16400, right? Okay, so the value of alpha is arc tangent 125x over x squared plus 16400, right? Note here, this value here must be positive, right? If arctangent a positive value, this means the alpha must lie within 0 to half pi, which is corresponds to the real world problem here, right? Okay, so this is the expression of alpha in terms of x. Next, let's have a look at question B. Find the exact value of alpha if x is 50 centimeters. So we can just put x being 50 centimeters in this expression. If x is 50 centimeters, alpha is just arc tangent 125 times 50 over 25000, 2500 plus 16400, right? Which is arc tangent 125 over 378. This is an exact solution for the second question, okay? All right, you can also check the complete solution in this lecture slides after the class. Okay, I'll give you 2 minutes to have a look at this. All right, so this is all we have learned for today. And let's make a summary for today's lesson. So now you should be able to understand the definitions of the inverse sine, cosine, and tangent functions, which are called arcsine, arccosine, and arctangent, right? And you should also be able to sketch the graph of arcsine, arccosine, and arctangent now. And also you should be able to understand and interpret the main properties of the inverse sine, cosine, and tangent functions. Then solve problems involving the arcsine, arccosine, and arctangent functions. Okay. All right, so the remaining time is for you to complete and submit today's homework. Okay.